Hey Tube, welcome back. Today we start a new course talking about the fundamentals of system design. And today we start with a single server setup. A single server setup refers to a system architecture where all components of the application are hosted and run on a single physical or virtual server. This setup is often used for small scale applications, development environments, or initial stages of projects. Let's try together to draw a single server setup and talks how it works. So first let's start here by taking a shape, and we will have a user. Okay, and this user might be on a mobile or desktop. Okay. Or web browser. Let's say web browser. I guess web browser would be better. And the web browser should communicate with our uh, our web server. But how can the user or the mobile or the web browser or whatever could communicate with our web server? In order to two machines to communicate, they need to the IP address of each other to call each other. So the user will use a service, a third party service that will called a DNS. Okay. And the user will try to send the domain name. DNS is short for a domain name system. And it will send the domain name like mywebsite.com. And just make this bigger. Okay. And the domain name system will send back the IP address of our web server or of the domain that have this the web server. Let's say 1215, let's say 15 1 to 5, maybe 3 4 and 2 1 4. Yeah, it's a solid IP address. Once the IP address is obtained, the user will try to make an HTTP connection with the IP address to the web server. It will use this IP address. And when the user and the web server will send back the data that which the server or the user is requiring. So, for example, we'll have let's say an HTML page, for example. So this is how a single server setup or single server system works. So let's say again the user access website through a domain name system such as mywebsite.com, and usually the domain name system is a paid service. It's a third party and not hosted by our servers. So we just use it. And after that, we have the internet protocol, like address is returned to the browser or the web browser or mobile by the domain name system. And once it's obtained, once this one the IP address is obtained, we will connect with the web servers with the hypertext transfer protocol. So basically, a hypertext transfer protocol requests are directly sent to the web server, and the server HTML or maybe the web server will return HTML pages or maybe a JSON response or photos, whatever the user is requiring. So right now we talked about all of that. We didn't talk about the traffic source. The traffic source here, as you can see in the web servers, it will be come from two things: the mobile and web server. In terms of the web servers, web application, for example, is used combination of server-side languages. Like we have, maybe we can use like Next.js, we can use no language I'm saying, so maybe Java, Python, etc., to handle the logic, business, the storage, etc. And we have like client languages like HTML and JavaScript. Right now, we can use React, also Next.js, and yeah, there is tons of other frameworks that can handle this for you. And in terms of the mobile application uses like a HTTP protocol to communicate. The mobile could be written by React Native or Flutter or yeah, or whatever it will be. Um, so right now the user will try to send a connection, and we might want to talk about how the retrieve data works. So for example, we will send like a get request. The user will try to send a get request to the web server. The get request will be like something like get all get users, and I will send the ID with the ID of 12, for example, or 13. And in return, I will maybe get an object, and this object will have like the data that is related to the user number 12. So, for example, ID it will be 12, and maybe we have a name like Muhammad, or address, phone numbers, etc. So right now, this is how the single server works, and as you can see, it's a pretty simple. It's really simple, and this is what it's a pros of it. It's simple. The simplicity of it. It's easy to set up and manage. All components are located in one place. It's quite cost effective as well, but we will talk about this in the next because it might get quite expensive in the future, and we will talk about how this is working. So. We have also low latency because we don't have no network latency between different components, since everything is on the same server. And the cons of this architecture: first, we have scalability issues, like limited by resources. We have CPU, memory, storage. Basically, we can it's a quite limited to scale. So if we have too many traffics, we can scale our server, but we can just add more resources. But we have some physical limits to that. We cannot add resources like endlessly. It doesn't work like that. So we will have some scalability issues. Also, we have a single point of failure issue. So basically, if this because if since everything is hosted on one server, so if this server went down, everything went down. So if the server goes down, the entire applications become unavailable, and no redundancy or failover mechanism is can solve that. Um, we have might can have like some sort of performance or bottleneck. So all services share the same hardware resources, which can lead to performance degradation under heavy load. We have limited maintenance flexibility, like it's difficult to perform maintenance or upgrades without causing downtime. And maybe one of you ask, okay, when to use this architecture, or what is the benefits of it? So you can use this one in development and testing, so ideal for development environments where ease of setup and low cost are priorities. If you want to use it in small applications, like suitable for small scale applications with limited user traffic and resource requirements. We can use it also for initial launch, so good for initial stages of projects to quickly get minimum available product up and running. So yeah, that's it for this video, and see you in the future videos.